Hi, I'm just going to take a quick look at the very introductory level Arduino sketch called Blink and see what it does and how to get your Arduino to do it. This is for those who have never even heard of it or held one before. So just a quick introduction. If you look at your board, you'll see a whole bunch of inputs, pins over here, some other ones over there, a bunch of other little circuit elements in the middle. What we need to worry about right now essentially is just this USB input. That's what we're going to connect to the computer, and we're going to want to notice one of these little LEDs that's embedded on the board right there. That's what we're going to use with the Blink sketch. Okay. Over on the left side of the screen, you can see the Blink sketch. We'll just take a quick walk through that before we plug anything in. This is exactly as provided by the Arduino IDE. We haven't changed anything. And you can see there are, down here, the main part of the program. Everything above that is a comment. See how it's light gray? And there are two functions in this. Every sketch has two functions at least. One is the setup, which gets the board ready to go, and the other is the loop, and that is the instruction that gets repeated over and over. So you can see in the setup there's one command issued, and that says tells the built-in LED what it's going to do. It's going to be an output. That's all it can do, but we'll see examples where that might be different later on. The next part in the loop, we are going to write a high signal, which just means turn on, to that built-in LED. Then we're going to delay for 1 second, or 1,000 milliseconds. Then we're going to send a low signal to the built-in LED, which means turn off. And then we're going to wait another 1,000 milliseconds, or 1 second. All right, so this is about as bare bones as it gets with the Arduino. Shouldn't have any hiccups here. The first thing to do is just connect your USB to your computer, and make sure in the actual Arduino environment that you've selected the right USB input. That can be found in the tools section of the menu, and you can go down to port and find the thing that looks like USB and select it. Once you've done all that, then you're ready to upload the sketch to the board. It's going to send it through the USB and dump it into that integrated circuit. And what we're expecting to see is this little tiny surface mounted LED start blinking at 1 second intervals. All right, so this little arrow up here in the top left, that will send the code to the board. Let's press it. And it's been received. The console says everything's okay, and now you can see this LED is blinking as it should. Not much fancy going on there, okay? But it does provide a good opportunity to just play with a little bit of code and see what you can do. So one of the obvious things we could do is change that delay, right? So if instead of every a second interval, we could change that to a tenth of a second, so 100 milliseconds. And now we should see a flashing LED going at a much quicker rate. I'll upload it. Takes a second, and there. Now you can see the LEDs blinking faster. Okay. So that's about as much as you would want to do with the Blink. One thing we could do to it to make it a little more interesting is instead of using the on-board LED, we could add another LED, an external LED that's brighter, and you could change the color and do whatever you want, make it a little more interesting. Okay, so let me do that by creating a new sketch. Okay, so I'm going to make a brand new one and switch over so that you can see it. There. So that is our brand new sketch. Nothing's in there, and we're going to want to copy the stuff from Blink, not all the comments and everything, but just the main instructions from Blink into that. It should look familiar. And we'll start by just looking at the board again and trying to understand what it is we want to do. So instead of sending the signal, the high-low signals to this LED that's still blinking, you can see I'm going to unplug the Arduino now and get it ready to modify our circuit. So now it's off. So instead of sending the signal to that onboard LED, I'm going to send it to an LED, one of these. Okay, and these we can mount on our breadboard. And now you'll notice if you look at a LED that there are two terminals to it, and one of them is a little longer than the other. You can see this one over here is a tad bit longer. And there's an important reason for that. Maybe if we get a moment later on in this semester, we'll look at the physics of what that's all about. But what it essentially tells you is that that needs to be the positive side of the LED in your circuit. Okay, so I'm going to go ahead and put that into my breadboard, just like this. So I'll put it over there on the right-hand side, and now I need to connect it to the Arduino. Okay, and I'll do that with just a couple wires. So the first one I want to do is let's establish the ground path. So that's going to be on the negative side of the LED, which, if you remember, is this leg right there. And so I'm going to go from ground on the LED over to somewhere nearby on the breadboard, just like that. All right. Now I obviously didn't connect it straight to the LED, you can see, and so there's one more step I have to do, and that is to add a resistor in between the LED and the ground so we don't put too much current through the LED. Okay. Or I guess voltage, too much voltage across the LED. We want some of it to be dissipated across the resistor. Okay. And so to do that, I'll take my resistor and I connect it to that red cable and the lower pin of the LED. Okay. So now you can see so far what I have is LED going to the resistor, going to the ground. The next step then would be to pick a pin. So let's try, we can say we're going to use pin number 2 as our control pin, and I'm going to connect that to the high side of the LED up here. So there's one side, and now we'll put this over in pin 2. Okay. So now we've connected one external LED to pin 2. All right, and the next step we want to do is modify the sketch so that we can address that pin. All right, and so first thing to do is to define that. So I'll add this line right here that says constant integer LED pin equals 2. So all that does is define the word LED pin as an integer, which is given the value of 2. Okay, and then I'll take that new variable and insert it in these commands. So you can see pin mode, my LED pin, which is pin number 2, is now an output, and I'm going to digitally write LED pin high, and I'm going to pause. Let's pause for half a second. Digitally write low, so that means turn off, and pause for another half a second. Okay, looks like that should be okay. So now I'm going to connect the Arduino. You can see it's still running the previous sketch from Blink, but I'm going to upload the new sketch. And as it does, now you can see that instead of the onboard LED blinking, that this one's blinking over there. Okay, and the fun thing you can do with that is change the colors of that LED. So that's a yellow LED. Maybe we would want to try it with a blue one, for example, if you wanted to get fancy. So I could. Well, you're not supposed to really do this while the thing's running, so we would probably want to unplug it, take out that yellow LED, and replace it with a blue one, and make sure to get the long terminal in the right side. So this pin here, the longer of the two legs, has to be on the positive side up there. Okay, and now we can repower the Arduino, and the same code will still be running, but instead it's going to make the blue LED blink. Okay, so that should be a fun little introduction to just getting your Arduino to do something.